Hello everyone and welcome to our presentation on information extraction using deep learning.
Here's an overview of what we will be covering in this presentation, starting from the introduction and objective to the scope of our project, literature review, methodology, output, and finally the conclusion. PDFs are everywhere in research, business, and even government use. But extracting useful structured data from them isn't straightforward.
Exactly, PDFs often contain unstructured layouts, images, and scanned text. Manual extraction is inefficient and error prone, so we have developed an automated deep learning based solution.
By combining NLP, OCR, and deep learning, our system can extract, classify, and organize data from PDFs, improving indexing, searchability, and retrieval.
Our main objective is to build an NLP based automated system for structured data extraction from PDFs.
We focus on extracting text and tables from documents like research papers, invoices, and reports. We also perform tasks like named entity recognition, keyword extraction, summarization, and classification.
OCR is used for scanned PDFs and all extracted data is stored in a structured format for easy searching and analysis.
The project covers five key areas. First, text extraction from both digital and scanned PDFs using OCR tools.
Second, entity recognition, identifying names, dates, organizations, and even monetary values.
Third, extracting tables while keeping their structure intact.
Fourth, summarizing long documents into short, meaningful summaries.
And finally, real world applications. This system can be used for legal documents, financial reports, academic research, and more.
To build our solution, we reviewed extensive literature on NLP models, OCR systems, and layout based document processing tools.
We particularly focused on models like BERT, T5, BART, and LayoutLM, which are well suited for understanding document layouts and language context.
These studies shaped the foundation of our methodology, helping us choose the best techniques for each stage of the extraction process.
Let's walk through our methodology. First is data collection. We used publicly available legal and form datasets and some synthetic data.
Next comes preprocessing. We applied OCR to extract text from scanned documents, then cleaned and tokenized the text and identified named entities.
Then we trained models using supervised and reinforcement learning. We experimented with multiple pre-trained models like BERT, T5, and LayoutLM.
Finally, the deployment. Our model can run either locally or be integrated into an online application.
Here's a quick visual of our entire workflow from raw input PDFs to structured data output. Every stage plays a critical role in automating the process.
Here is a look at our results. On the left, you can see the pre-processing steps like tokenization and OCR alignment.
And on the right, we show the summarization output. Our system condenses lengthy legal documents into precise summaries using NLP models.
To conclude, we successfully implemented LayoutLM for document information extraction and applied NER and summarization on scanned PDFs.
Our next step is to integrate the NER output directly with the summarization engine, providing even richer insights.
Future improvements will include better entity level summarization and visualization of the combined results.
So now jumping to the training part about how we train the model. So as you can see, you can get the necessary data set, install our necessary libraries, and then we change our directory to the our required UNLM and LayoutLM packages and install them. So after that, we checked our dataset of the images and the JSON file, which is the annotations for the training part. This should be how our output file look like. It's one of the training data outputs. So we pre-process the data using the Microsoft LayoutLM preprocessor. After that, we confirm our labels, make a PyTorch dataset, make a label map, then we tokenize our input. After the tokenization, we define and fine-tune our current LayoutLM model with our current labels, after which we start our training process. Currently I have taken around 25 epochs. You can increase it, but as our dataset is around 200 images, so that was good enough. So after going through all the epochs, we evaluate our dataset, and evaluating it gives us a good F1 score. It's pretty good in my opinion. So you can see the evaluation metrics right here, the various steps and losses. Graph would be like this. And so now, after all of this, we can finally use our model like this. So after we save the model locally, then we can load the model. We can take a testing document, and using PyTesseract and pillow and PDF to image, we convert that PDF to various images, and then we label it to get our final output. Then after getting our final output, we go to our summarization model. Our summarization model is then finally trained on our cluster NDA dataset. After fine tuning the summarization model, which is the Facebook BERT model, we can input our text which was retrieved from the LayoutLM, and a summary will be generated. So both the outputs, one would be this boxed output to visually inspect our document much clearly, and we can go through our documents much faster, and we also get a normal text summary output.
Thank you for watching our presentation on information extraction using deep learning.